Please say something if you can see my screen.
Yes, we can, sir.
Okay. So Terraform. So like we mentioned, Terraform is infrastructure as code tool. So what we have been doing so far, we have just been, writing stuff basically. We have just been writing stuff. We have just been clicking here, click here, you click this one, you click. However, that is fundamental knowledge. It is very rare situations that people will actually pay you to come and click on any cloud environment. As a cloud, the reason why we learned we call it click ops. So the reason why we learned click ops initially for it is because you need to understand the manual processes. If you don't understand this manually, how will you automate it? It's not possible. So now that you understand, okay, how to set up VPC, don't worry. For your next task, you know me, I always like giving expo. For your next task, you're going to repeat everything you did for this last task, but you're using Terraform. So you're going to do a custom VPC, subnet internet gateway, EC2. Now you will log into the EC2 from your Terraform code you install. So you not do the one that you enter into the AWS into the EC2 to install Docker. From your Terraform code, you do the Docker installation from a Terraform code. So when you launch a Terraform, everything will run. Yeah. Then you also deploy Terraform on CI/CD as well. That's by the way. So what is infrastructure as code, first of all? Infrastructure as code is is a way to define and manage infrastructure using code rather than manual tricks. Rather than manual clicks. So instead of all those manual clicking that we're doing, you click here, you click here, you click here, you click here. The best thing to do is one, write your IAC, write your IAC code, you apply it, and then the application goes directly into the AWS or any cloud. In fact, the good thing with Terraform, yeah, I'll go over that in why Terraform over cloud formation and CDK. The good thing with Terraform is that okay, let me first of all talk about infrastructure as code. It is a very, very unique way to define your infrastructure because of number one, automation. You know, it's you automate the processes you want to go through. It helps in repeatable deployment. So for a situation where you want to deploy a particular resource multiple times across multiple environments, you won't want to go and start clicking. Probably, for example, you have a dev environment, a staging environment, and a production environment. You won't want to start going to do those whole clicking processes in those whole clicking processes in just one environment, in just 3 times or across multiple environments. That's why you use infrastructure as code, because with infrastructure as code, you can define and manage your infrastructure using code rather than manual clicks. Now, the benefits are one, automation. Like I said, with automation, you can repeat the same deployment across multiple environments. That's very, very, very good. Two, version control, like we mentioned, Git. You deploy, ideally, most companies, most industries, they deploy Terraform code via version control, which is via Git. Same thing you did on GitHub Actions. It's the same thing you would do when deploying your Terraform code. However, for our project here, we may do it. Okay, I will teach you how to deploy it manually, but during the task, you will have to deploy it on with GitHub Actions. But be careful though. It's a caveat, which I'll mention at the end. Now now with infrastructure as code, there's collaboration. Now in collaboration, multiple engineers can work on the same infrastructure. So if you're in a situation where you're not the only AWS engineer that's managing that infrastructure, you have to implement your infrastructure as code, because Nobody's going to come to your code and then find out what and what you clicked to get X, Y, Z done. They won't they won't know. You get, they can just come over and see, oh, an EC2 instance is connected to this. Where is this EC2 instance coming from? Nobody knows. But if you have a properly documented infrastructure as code, they can be easy to, they can read the code and understand how the infrastructure is put in place, and find ways to better modify it. Just like having your normal back-end code and front-end code, you get. And consistency. That's the key word for infrastructure, consistency. Your infrastructure is consistent, not the one that you can be using 500 gig for one setup. The next setup now you can be using 200 gig. You understand? That holds infrastructure cost, because as an engineer, you won't remember everything when you're using ClickUps. So that's why infrastructure is cool. So that you know that if you are deploying a particular setup like that again, it is just an automated process. It's like a lift and shift, basically. So yeah, now we go to Terraform. Terraform is a Terraform is a open source tool by HashiCorp. Terraform is an open source tool by HashiCorp that helps you to deploy infrastructure across multiple cloud providers. So, like, what am I saying? Terraform works well with AWS. Terraform works well with Azure. Terraform works well with Google Cloud. Terraform works well with DigitalOcean. Terraform works well with Kubernetes, cloud native environments. Terraform works well with on-prem. You can even deploy Terraform set to your on-prem server. But that one comes with its own configurations. But yeah, Terraform, Oracle Cloud, Terraform, Huawei Cloud, Terraform. So Terraform is ideal because you can use it to provision your resource. So if you are building an infrastructure that transcends across multiple cloud providers with the same underlying configuration, Terraform is perfect because it you help to you can the same setup that you did with AWS, same setup. The code base will be different because they are different providers, but you can consistently manage the infrastructure change and modifications across multiple providers because they are all banking on the same Terraform underlying. Now, Terraform, there's what they call an infrastructure life cycle, and Terraform manages this infrastructure life cycle properly by provisioning this infrastructure, um provisioning this infrastructure, updating the infrastructure, and destroying the infrastructure. So with one command Terraform destroy, you can destroy the infrastructure. With one command Terraform apply, you can apply some certain words conversation from some certain resources. Now, people may ask, there's also CloudFormation. So CloudFormation is AWS's native IAC tool. CDK is also the same thing. So it's also an AWS cloud development kit. So it's used to build resources on the cloud. Now, people may ask, why Terraform over this? CloudFormation is perfect. I recently worked on a project and then it involved me doing CloudFormation. I don't know as much CloudFormation as I know Terraform, but I was able to do it, I was able to find my way because I know CloudFormation to a good extent. But ideally, Terraform works well. 90%, 80 to 90% of companies that run cloud providers use Terraform because one, there's multi-cloud. So it works across multiple providers. So if in a situation where, oh, I need to move from AWS to Azure, all you need to do is just to change your provider one and then change some resource and some configurations, and you're good to go. The same setup that you have will be the same setup that you have in your new provider. And unlike CloudFormation and CDK, there's only AWS. So if you want to now move across another infrastructure, you have to now start doing some code-based build up from scratch. You get. So Now Terraform uses HCL, which is HashiCorp configuration language. You get Terraform uses HashiCorp configuration language. So it is the native language for Terraform, which we will learn probably on Friday when we're doing hands-on. But CloudFormation, they use YAML, which is the basic YAML, but you get to learn about Terraform's HCL, language. Please, is anybody following? So, please confirm if you are following and if you can hear me.
I can hear you and we are following.
All right. So, in Terraform architecture, there's a Terraform providers. There's Terraform providers. There's Terraform states. There's Terraform backend, and there are Terraform modules, which we will talk about in the following sections. So there's Terraform basics. So when we talk about Terraform basics, we talk about providers and resources. So Terraform providers, if Terraform provider is basically a plugin that allows Terraform to talk to other external services. So the bridge between your Terraform code and your infrastructure is what they call the provider. So the provider, there's the AWS provider, the Azure provider, GCP, Kubernetes, all of them. Terraform provider. So it's the provider now that link. Now, how it links is through on AWS, you have your IAM rules. You get on AWS, you have your on AWS, you have your IAM rules that you get your credentials from. So when if you want to if on setting up on setting up AWS Terraform, you download your AWS CLI, you configure AWS CLI on your local machine with your laptop. Then you get credentials from IAM rules, which will give you user and secret key, user key and secret key. Once you've gotten your user key and secret key, you add them to AWS CLI. And then what Terraform now does is that once you set in AWS provider, it goes into your machine and looks for the credentials that were connected to your AWS CLI and then connects with it as well. So once it connects with it, it now forms the direct route between your code and the AWS environment. So once you apply, you do the application, it just pushes your code up there. Now there is the variables and output. Now a variable on Terraform is used to make code dynamic. Just the way you have, for those of you that have coding knowledge, you will know that for those of you that have coding knowledge, you will know that when you have a particular um, variable that's constantly repeated, a particular value that's constantly repeated in your code, you would want to declare it as a global variable that anytime you have that, you want to call it in your code, you just reference the variable wherever it is. That's what Terraform variables also do. So Terraform variables, if I have probably I want to set an EC2 instance now, and I want to set two EC2 instances, and these two instances are five. Let's just say are T2 micro. If I'm writing the code to set up these two instances, I won't go and write 2 micro twice. Oh, this one size T2 micro in the first one. Next one size T2 micro. What I'll do is that I'll declare that size as Terraform variable. Then when I can just name it size, the variable will be named size equals to T2 micro. So when I'm creating the resource, I can just go and put size equal to variable, which is var dot size. So to go and look for the variable named size and then infuse there. So I can call it out in any part of my code. So that is what variables are. That's it about that. Then output. So output are just like the way you say output. So outputs are like the output of a particular resource. So for example, now let's just say they are used to display information about your infrastructure when they are created. So if you're building like an EC2 instance and you want after the instance, you should expose the IP address, public and private IP of the address created before you even go and look at it on the AWS, you expose it on your CLI. You now set it as an output. So you can write an output, or this output will be the IP address of this thing. So once that it has done the application and done apply complete, it will now show you the IP address. So you can further use that IP address now and do other things, which will be part of what your task will be, because it's the IP address that will come out in the output that you use to SSH and do all those stuff. Yeah, so that's just what it is. That's variables and output. So variables is used to set what, you want to make code dynamic and reusable. You want to make a particular component reusable. You said put them in variables. Now output is used when you want to make certain commands. When you want to make certain commands, you want to get the output of a particular um resource. Then now there are Terraform commands. They are important, very, very important Terraform commands that we need to know. First one is Terraform init. So what does init do? Init initializes a project. So the way you have git init, when you create a folder, you have git init. Terraform init. So what Terraform init does is that it initializes Terraform in the project. So when you run, for example, now I want to start a Terraform project. Once I create my folder, first thing I'm going to do, Terraform init. Now, what this init does is that it creates a state file, which we will talk about in the next step. That state file is a manifest. It's a record of everything that you are doing, within that infrastructure. So if I write the code to deploy an EC2 instance, and I deploy the instance to record in the state file. If I say I don't want the instance to be deployed again, I destroy the instance, it will record in the state file. So that's what Terraform init does. Now, after you're done your Terraform init, I've already even explained state file for yourself, but I'll continue. After doing Terraform init, you have written all the code, all the bobo up and down code you want to build. You now do Terraform plan. So Terraform plan is like your view. When you finish writing something, for those people that they always say at the when you have drawn something, you look at it to determine, oh, this thing is beautiful. That's what Terraform plan is basically. Don't mind me. Terraform plan shows you what and what and what and what you have designed, what you have written, how it's connected to each other, what and what is going to be deployed, to show you, EC2 instance in this Kine VPC, then a subnet, to give you like a complete breakdown of everything you're written for you to know. Then after that is the apply. So Terraform apply. Now the apply now is what now does the main application. So once you now do Terraform apply, now Terraform apply is now what we go to, take those resources down and then create them in your cloud environment. After it is applied, now you want to bring it down. You don't want to do it again. You do Terraform destroy. But be careful, Terraform destroy is a very, very dangerous tool. So people don't even use it a lot. But I'm just telling you, especially when you're working in an environment where you are working in a large scale infrastructure, you can't do Terraform destroy or Loro margin, God forbid. But it's just used to bring down your infrastructure, destroy, terminate everything terminatable. All those things that you go and do when I say take down all the instances to remove cost, Terraform destroy. Now there's Terraform state file, like I mentioned before, is a manifest that takes record. So after you're done the init plan apply, when the thing is applied, once you apply it, it is writing it down somewhere. Oh, that XYZ is going to be applied at XYZ time. So it's using XYZ size, XYZ this, T2 micro, kini. It's all recording in the state file. Now, this state file is the most sensitive document in your arsenal, and it must not be kept anyhow, because this is the state file that any engineer that wants to come and work on this project later, it is this state file that they will reference when they want to do their stuff. So you have to keep it safe. This state file you're seeing here is like environmental variables. So it's as sensitive as env file. So what do you do when, now you can see, if I go back now, you will see there, I talked about provider, I talked about state. Then you see the backend. Now, this backend is where you store your state file. So when you are making your provisioner, AWS, or your provisioner is what, AWS, you want to store the state file somewhere. Now, what people will do is that they will create an S3 bucket manually. Then now call the S3 bucket when they are doing their Git. So when they write their provisioner, when they write their backend, they will not call the S3 file. They will not call the S3 file, the S3 bucket while there. So when they now run git init, instead of the state file to be stored on your local machine with your laptop, it will be stored in the bucket, which is ideal for a production environment. You always store, that's why it's object storage. You always store your state file in a bucket or in Dropbox or somewhere safe, that anywhere that wants to access that resource, probably another engineer now wants to work on this thing, they can just, when they initialize it, to go and pick the state, the current state from the bucket. Because if you can't deploy your state file in your version control, which is your Git, someone can just go there and then look at everything. It's like a record. Look at all these things that have been created, and then they can tamper with it. So I'll show you one of my repos. The plan is to show you one of my repos after this class. Then we'll talk about, then when we settle Friday, we'll now do hands-on. I'll show you how on the hands-on, I'll deploy a simple EC2 instance. Then we'll now do your tax, which will be the whole thing you did. I'm not going to change the question. The whole setup that you did for the last exam, just do it in Terraform. It's simple. Yeah. So there's the input value string. So this string now is, there are some times when you want to impute something. For example, now you want to set T2 micro. So your size now is a T2 micro in your variable. You put it in a string. So if I put size now equal to T2 micro, I won't just put T2 micro like that. I'll put it in a string, which is, double quotes, and then put T2 micro to recognize that as a string. And then when it's deploying, to go and look for where T2 micro is defined, and then now call it, it will now call it, and, do it also. There's also list. There's also map. List, the same thing, you put in a list and you can give it an array. So if the variable, now for example, when you're setting security groups, and you want to set multiple security groups or multiple IP addresses, you put it in a list. It is square braces, square brackets, you put it like that, list, then you put the list of stuff. Then there's map as well. Then there's output values, the same thing. Same way there's input variable, there's output variable, which is the one that I told you about. Um, This is the one I told you about, getting if you want to get the output of a particular resource, probably you want to get the IP address of the server you just created from your CLI and this one. Then data sources. Now, data sources are like already existing. They are already existing resources. So for example, now there's sometimes when you want to, probably um, you want to create an EC2 instance, but you don't want to create a VPC from scratch. You want to use an already created VPC, which is like the default VPC. You get it is a data source. So you now use what they call a data source definition to extract the VPC ID. You understand? So when they say because part of the EC2, when you want to create an EC2, I'm always referencing EC2 because particularly what you would start with. When you're referencing EC2, they'll tell you which VPC you want to put it. If you did a custom VPC, you will just reference the ID of the VPC that you've already written. So each resource has an ID. Each resource has an. So when you create AWS VPC, you put a VPC name when you're creating your VPC resource on Terraform. When you now want to create EC2, you now go and reference it, what you created .id, which is so if you get the ID. So it will, what it means that you should go and look for where this resource is created and get the ID and infuse it in this EC2 part. However, if you don't want to now you're not building a custom VPC, you want to get the already existing VPC, then you go and get a date. So it will be defined as a data source. So data source is when you're already getting already existing infrastructure into your new infrastructure. That is what they call a data source. Then there's variable files. So that variable files that I shared for you, the variable files that I shared for you, um, so when you want to declare put variables, which is let's say the size is equals to T2 micro, you declare them in files called and as they will be tagged TF vars. So when Terraform sees any file called TF vars, that's where you should pick the variable from. So if I'm referencing size in my Terraform, probably I reference size. I can put T2 micro on my VTF vars. Once I go to my EC2 and I want to put size, I can just put var dot size, because size is the key that's already referenced in the variable file, and the value of that key is what? T2 micro. So if Terraform goes and try to create the instance and it goes to size and it sees var size, it automatically go and look for the TF vars and look for size defined in that TF vars and get the value from it. So that's what it's just like .env, the way you have .env on your normal, coding. That's what this is. So yeah, now there's state management. So I mentioned about Terraform states. There's a local and a remote state. So the local state, now, like I said, when you create what they call it, when you create when you create Terraform init, it will create a state file for you if it is not already existing, probably your new project. To create a state file for you. And that state file will be stored as terraform.tstate on your local machine. However, you don't have to, you're not meant to keep that state file in your local machine. Now, it being in your local machine is what they call the local state. It's on your local machine. Now, most people, that are not security conscious, they can just be passing around the state file and stuff. It's as far as in your local machine, it's a local state. However, what makes it a remote state is when you now set it on a back end. So that functions of it being, oh, the state file is on a domicile somewhere on the cloud that once you initialize to pull from there, that is where it's a remote state. So that is the local versus remote state. You get me? Then there is the backend. So the backend is where what houses the remote state, which is S3 plus DynamoDB. So DynamoDB is to lock. DynamoDB is used for when you want to like lock and control the change, like the amount of change people are making to that state file. Use DynamoDB. But however, you can just use S3, just for storage. Then state command. So state command is when you You want to view the state of the state, basically. Because there are some times when, for example, you have deployed a particular resource, something happened, a configuration happened, and then you have to go and now delete that resource manually on your console. However, when you do that kind of thing, your state does not change. And for situations where when you have deleted that thing on your console, you now have to remove it from the state. So you do your state list, then you do your remove state RM, the exact, because if somebody gets hold of that state, your state shows that resource was there, but you have already gone to remove it manually, and it will cause configuration drift over time. So state commands are used when, okay, something happened, probably there was an emergency, you needed to adjust something, and boom, you can remove, which is very, very unideal. You have to remove it manually from your state. It's like a surgical process. You remove it manually from your state. And then once you remove it manually from your state, and you do your, you do your Terraform init, it will now, properly align to the states. Because if you're gonna do Terraform init or try to, run any new change, it will go and look for that particular resource that you have deleted. And once it does not find it on AWS, there will be a configuration drift to keep throwing you errors. So that's what state commands are used to list the states you know, to see the state, your state file. So the state file will show you, this Terraform list and Terraform show will show you everything that you have deployed, the size and everything. It's like a document, it's like a manifest. When you want to enter a plane, you try to have a manifest of the number of passengers and all those stuff. That's what the state file is. So next one, there's file provisioners. So there is provisioners. Now, you can deploy a resource. You can deploy a resource, and then when you deploy a resource, you want to go into that resource and do something useful. Like the same way I told you, you have to go into it from Terraform. That's where you use provisioners. Now, what are provisioners? Provisioners are used to execute scripts or command on a resource after it has been created. This helps with bootstrapping or initial configuration of infrastructure when Terraform alone is not enough. You understand? For example, where you want to even use Ansible to connect to you want to use Ansible. I did a project one time where after deploying the after deploying the EC2, I used Ansible to now do one kind of setup inside the EC2, all within the Terraform environment. That is where you use provisioners. Now there is the local exec and there is the remote exec. So what is the local exec? Local exec runs commands on the machine where Terraform is executed. So for example, if I am running Terraform and I want this particular So if I'm not, what the local exec does is that if I'm running Terraform and I want a particular script to be run before or after the resource has been created, that's where you use local exec. So I want a script to run immediately. For example, now I want a script to run immediately my resource is created. That will just show me resources created. That's where you use the local exec. Local exec is not really, people don't really use it because it's of no use, to be honest. You just want, except you want to like run like a cron job or something that will run either pre or post your infrastructure provisioning. Yes. That's when you use what? Local exec. But remote exec works when you want to run commands inside that resource via SSH or via anything you want to do, probably database or stuff. That's when you use remote exec. So remote for EC2 instances, you most likely will use what they call it SSH keys. Use SSH key to enter into. So it is within the process. If this will happen within your provisioning, after it has created the EC2 instance, you do a remote exec into the instance. That remote exec now do probably sudo out update, sudo apt install Docker, sudo apt Ubuntu AG to change group, blah 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 blah. When it is done, that's when Terraform will tell you that the application has completed. So even if the resource has been created and the remote exec fails, your entire Terraform will fail. That's what remote exec does. Then there's a file provisioner. File provisioner is also useful when you want to copy file from your local machine. I think this is what I even did for that simple thing. I can't really remember. File provisioner is useful when you're within your Terraform environment, you have like a script. However, I think this is what I did. However, you now want to move. So when you create the resource, your goal will now be to move that. Your goal will now be to move that file to that EC2 instance inside and run it. That's when you use what? File provisioner. So you should understand the three of them. You should understand the three of them. Now, like I said, when and when not to use provisioners. Local exec is when you want to run script, either pre or post the provisioning process. If you want to run a script before your provisioning starts, that will help the provisioning, or if you want to run a script after your provisioning has been executed, that's when you use what? Local exec. Now, remote exec, if you want to run a particular setup within the resource, like SSHing into it and installing something, that's when you use remote exec. You get. Then file provisioner, if you have a particular file that you want, probably you have an SSH a shell script that you want to execute. Probably you have a project that they will tell you, okay, once this thing is launched, launch this setup, to automatically provision this stuff. You want to use file provisioner to pull that, you copy that setup to your server. And then this file provisioner is useful for if you want to set up all this Nginx with Nginx configuration file. You may have the configuration file on your Terraform project. You can just copy it into the EC2 and then run it. Automatically provisions in Nginx for you with all your set bot and all those stuff clean. So yeah. Omo, any question? This is a very, very thorough project. Very, very thorough stuff. I'm just doing a lot of talking here. So when we start doing hands-on, you see it live. Anyways, moving forward. Now there are Terraform modules. What are Terraform modules? Terraform modules are reusable components of resources that are grouped together that can be reused. So it's like creating a library, and it's like creating a library of resources that contain their own individual configuration. Then you now use them. So on your Terraform project, instead of building the resource from scratch, you now go and call the module that you have created and use it to run your infrastructure. So it is very, very useful because it's like the way you have functions exactly. So in your programming, the way you have functions, where you define a function, inside that function, you define whatever the function needs to do. And then within your code, if you want to now do that thing that's inside that function, instead of writing that code from scratch. You just call out the function. That's basically what modules do. So modules on Terraform is like functions in programming. So you define your modules, and then your root module, which is where your main configuration, you just call out the module you want to use. Probably specify these variables, and then you can use it. It is good when um it's very useful in situations where English has eluded me. It's very useful in situations where you have multiple, have multiple environments. Yeah. I don't want to now start. For example, now you're building Terraform across dev staging and production environment. You don't want to now start building writing EC2 instance code 3 times. Just write a module, then call the module in the different environments with their different sizes, separated, but they're still rooting from the same module. And boom, you have 3 different environments up for sale. Now, aside from the modules that you will create, there are also Terraform registry modules. So that's the way you have GitHub Marketplace when we're doing GitHub Actions. The same way this one will work as well. So Terraform registry modules are registry modules that instead of you writing the code from scratch, you can just go and pull up a module and you know just fill in the variables, and it will now go instead of you it will now go and pick the module from the registry online and then use it. So if you were in the if we're doing the when we're doing the GitHub Actions class, that whole setup where we had GitHub Actions, Marketplace Actions, that's the same way we have it Terraform registry modules where you can just go and then get resources, Probably, for example, now we don't want to build a VPC. Yes, you can decide to do it, but I would advise to build it from scratch. But for me personally, sometimes when I don't want to build VPC from scratch, all the networking, I can just go and get a custom module. Once I define the I cannot go and get a registry module. Once I call out the registry module, all I need to do is just to put my IP address and everything, and boom, a full VPC is set for me. But for learning purposes, I would advise you to build the whole stuff from scratch. Then the registry modules are available for all the components you want. So yeah, but some people can just be dogging. But there are sometimes when registry module will not help you, especially when you're building complex Kubernetes on EKS. Registry module will not help you. You have to build the whole system from scratch. So yeah. Um So yeah, this is the end of my slide. I will want to go. First of all, I want to take questions before I go to my GitHub repo to show you a sample Terraform project so you know how it looks like. Any question? Is there any question? Please, if you're saying anything, I cannot hear you. If you're writing on the chat, let me even check the chat for moving forward. Only one person is replying, no, sir. Okay. I don't know if I should call it go by name. I feel like everybody here is an expert. Okay. So this is a sample Terraform project to deploy an S3 website. This project basically has everything you need. First of all, there's the providers. If we go into the providers now, you see how it's structured. Now you see Terraform, required providers, AWS. Now you can see AWS is here. If it's Azure now, you will see Azure. If it's Google Cloud, you see Google. Google is just named Google. Then you see source. Now this source now is going to pick the AWS provider that will help you to, connect with the credentials on your laptop. Version. Now, this version is trying to tell you that anything greater than this is anything greater than 4.0. So 4.0 here is the minimum. That's what they're trying to tell you. This is actually good because when new versions come, it will just replace and then tell you this. If you don't put these two things here, you just only go and pick 4.0. And if 4.0 becomes outdated, your code will have issues. Now, you can now see the back end. Now, for this project now, I have to now I have to go to go to S3, created a bucket called this, and I came to call it here. This is the bucket name. Now, this key is the folder inside the bucket. So inside the bucket, I made the folder static sites. Inside the folder, I made a bucket called inside the bucket, I made a folder called static site. And then this is the name of my Terraform file in my local. So when you do the Terraform init, to tell you to create a file called terraform.tf state. I put it here so that it is going to look for a terraform.tf state in my local and then map it to this static site. So it will now be static site slash terraform.tf state inside. Then region is here. So that means this region now is trying to tell me that anything I'm provisioning here now is going straight to US East 1. So this setup now is provisioning for what? US East 1. So this is the first thing that you usually do when you are starting what a Terraform project. Now, variables. And this is how variables look like, basically. The variable is a domain name. The variable here is domain name description. Variable. I didn't put my TFVALs file because it's for security reasons. But now, after these variables, now it's now going to pick type string. Here, type string. You now go to your Terraform.tf file and then define domain name equal to the name of the domain name. Subdomain is equal to subdomain because it's a string. But this variable.tf is to define the variable type. So if you want a string, if you want a list, if you want a number, blah, 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 you define it here. Then when you go to your tfvars file, you now call it the raw form. That one is also a very, very protected file as well. Then look at your modules. Now, this is how modules are created. This is how modules are created. You can see CDN, certificates, DNS, and what? Storage. So let's do storage. This storage now is S3. I'm creating an S3 resource. You can see resource S3 bucket, AWS S3 bucket. This is the name S3 website. Bucket variable dot bucket name. Inside the main here, the bucket name now calls subdomain and domain from variable. So inside here, you see main variable.bucket name, website. These are all the everything uploading to the bucket. These are all the setups which I cannot explain now. Then inside each module, you also set up variables and output as well. The variable bucket name, CloudFront AI, CloudFront this. Then output as well. If you want the output, so the output will be the bucket regional domain name and the bucket ID. That's what to come out on your CLI. You define the same thing as well, DNS. So this DNS now is Route 53 for domain name. So I want to register my bucket into a domain name. I set it here for Route 53. I'll do the same thing to set up the variables as well. Certificates, same thing. Write the code. Then the CDN, which is CloudFront, did the same setup as well. you use the origin access identity and the rest. So for each module, you have to define a variable, your variable, define how the variable should be type string, this. Then on your main.tf, it is on your main.tf that you will now come and now call out. Now you can see I did data here. So this is how the data is going to define the data source. There's already a hosted zone. So a hosted zone is like so when you want to create a new domain name, you have to create a hosted zone. It's like a house that houses your DNS setup on AWS, a hosted zone. But since there's already a hosted zone, I just went to call out the hosted zone, which is, this. So it will go and look for where, than this var is domain name, to go and look for where domain name is this hosted zone now, to go and look for where it is and then get the value and then private zone for. Now, we will now call out certificate. So module certificate. Source, you can see the source is .module certificate. It's going to pick up from here. Domain name, var.domain name, subdomain. So it's going to pick this set of these variables now are under certificate, which is what is here, under here. When we're defining it in the roots, we'll now go and under this root, we'll now go and look for it in these other root variables, or we can define it here if it's not that too secure. Now zone ID is going to pick data dot AWS route 53, sorry, AWS route 53 dot main dot zone ID. So the zone ID now will be created when the thing goes to pick this hosted zone to get the zone ID and then pick the zone ID out. Same thing we'll do for CDN, same thing we'll do for this. So these are basically a rough sketch of how a Terraform code looks like. And this is just very small. You may think it's plenty, but let me tell you the truth, this is small. There are some codes that are up to like 200 lines, especially when you're dealing with large scale, complex production environments. So yeah, this is how it looks. This is how the modules are defined. Don't bother yourself about the details of the code. It's just how it's structured that I want to focus on, basically. Now there's variables, and yeah, so this is the provider. The provider, I removed this backend because it was causing, and this is just a test code, by the way, it's not production. I was trying to build something for someone, then I needed to test it on my own AWS first. So when it worked now, and I wrote the main code, it requested AWS. So yeah, provider AWS region, kini. So that being said, any questions so far? Why is it there's only Fatima that's asking questions and replying me in this class, please? I'm going to start calling people one by one. Bash. I've talked about how using full names on, say, Cohere the hot, no questions. I've talked about using full names on the chat. Bash, is there any question you have, or any feedback, or any observation that you have so far?
No, sir.
Okay. Abdul Samad, any feedback, question, clarity, any of them?
The only question I can say I have was the previous task.
Don't worry, we'll come to that after this one. When I've gone around. Please mute your mic, please. When I've gone around here, we'll talk about that. Who else? Karen, good evening. Any questions so far?
I was having network issue, so I didn't really get the class.
Okay, so you don't have any.
Yeah.
Isaac Abaje. Sorry if I didn't pronounce it right. Any question?
No, I don't have question. But maybe at the end of the class, I have a question to ask concerning the last task.
Whoa, don't ever asking questions for the last tax. Okay, teams. I think that's a team book. That's a team. Please, I beg. I don't want to have to confuse myself about. Please try and adjust your name for the class, please. Teams, is there any question?
Nope, not at all.
You sound confident. It's good. Who else? Who else? Fatima, is there any question? Abi, she's not in class. Okay, Fatima is here. Any question?
Currently, no, sir.
All right. Who else? Who else is here? We fish out people that don't say. I think this guy Ayus has gone. All right. So those that have questions regarding the last class. Then there's Temitope. Yeah. Temitope, do you have any question?
No.
Okay. Oh.
Hello?
I can hear you. I said okay. So those that have
Oh,
questions, who indicated he has issues with the last tax? Please speak up now or forever hold your peace.
good evening, sir.
Good evening.
Uh, it's concerning the last task.
Okay.
I I use I did my own assignment on Azure, but because I was unable to create a AWS account.
You should not do that, bros. Actually, you're the one that I
So,
was calling out on that group.
okay,
Anyways, find someone that will give you IAM access. One of these people that have done, ask for it, IAM user access. They're all of you are cloud engineers, you will know how to get IAM user. They should get you an IAM user so you can log into their own account, do your assignment and delete it. Or if
okay.
it's not possible, if they don't give you IAM access before the end of tomorrow, tell me.
Mm,
I'll give you IAM access on my own account. But you don't do that. If you have issues like this, you report back. Because we
okay,
are only allowed to use AWS, not Azure.
okay. I'm sorry
So
for that.
if you don't get before the end of tomorrow,
Mm,
reach out. reach out to me. Then I'll give you provision IAM user for you on my own account.
Okay.
Well, just try and look for someone that will give you. You may not have the account by yourself, but if someone can give you administrative access, you can get it
Okay.
done. But please, once you're done with your assignment, delete your resources. I don't want to
Okay.
see any careless debit alert, I beg. But find
Okay.
someone around. If you cannot get it, reach out and adjust
Okay.
their assignment and resubmit.
Okay, sir.
Thank
Thank you,
you.
sir. All right.
Any other issue? Some other people that said that they have this thing.
Sorry, sir. Let's start Terraform. Terraform,
So
and are you going to be using AWS?
you say what?
The next task is it on Terraform and AWS?
Yes, now we're going to use AWS. Yes, to provision Terraform. It's AWS now. We're not learning AWS manual one, then come and use Terraform another one now. So we're using
Okay.
Terraform AWS. So you'd have to install Terraform. It's a very simple process. Install Terraform on your Windows or your laptop. Go back to your cloud provider, get credentials, access key, and secret key on IAM. Install
But
them
what
on.
about all these variables and are
Huh?
we going to be writing them from scratch?
Yes, now you are writing everything. Your next task is practically just the last task you did just in Terraform. That whole VPC subnet,
Okay.
internet
But
gateway, everything with EC2. You are going to do it with Terraform. So you are practically repeating the whole assignment you did the last time with Terraform. Now, when you now create the EC2, you use remote exec to install Docker. You get when you now use a remote exec to install Docker, then you now do your CI/CD. So it's a full chain process. I will give you better breakdowns when it's time to do the tasks. So I'm not giving you different thing. The only thing is after the Terraform class, you only to repeat the whole assignment. So for those that did the assignment, it's a plus because you repeat the whole assignment you did with Terraform. So you do your Terraform will contain your VPC, internet gateway, kini, subnets, all of them. Then you use that one to create a VPC, use that one to create an EC2 with security groups, and just like that EC2 now remote exec to submit. I want to see your remote exec to install Docker inside. Docker and Docker Compose. Yeah. Yeah, I can hear you. Abdul Samad, I can hear you. This thing is echoing. Please, can you I'm echoing in your background. Please, can you mute your mic? Please, I beg, before you unmute your mic, find a better background, I beg. Please, before you mute your mic, find a better background. I can't be echoing in your environment. Please, have you found a better environment so you can unmute and ask what you want to ask? Hello, Karen. Do you have any issue with the last tax?
No, sir. No.
Okay, well, I'm expecting your submission. Um,
Right, sir. I need to submit that.
all right. So that being said, um, yup, 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 yup. Abdul Samad, are you ready to, should I unmute you so you ask what you want to ask? The class has reduced drastically. Hey, hey, the chaff has been weeded out. Ho, 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 ho. Or these are the chaff has been weeded out. These are only so far, we see the last class. It's as if for every tax I give you, this thing slices into half. This thing, okay, phone mic has issues. You can type your question though if you're having issues. You can type your question. For every tax I give people, this thing reduces by half. The other tax, it was only 16 people that submitted. Now this one, so far, just like 7, I be 6 that have submitted. Please, oh, make una try enter finalist, abeg. Let me have at least, even if you at least 5 finalists from DevOps. So that it will be shared across board to your different projects. Because like I said, final stage, you all will be grouped. Before it's like a startup, basically. People form a startup. You build your stuff. You have meetings every day. I won't be there. You have your meetings every day. You build your stuff. You know, at the end of the class, you demo. Best demos, I think they go with prizes or something like that. So yeah. Okay. So in the absence of any other feedback, okay. No more, I just want to continue using workflow run. What do you mean by workflow run? Workflow dispatch. Okay. Say I use and Wilfred, don't collect that one. Don't assume, oh, don't assume. Adebanjo, good evening. I think you're having network issues. Were you in the most of the class?
Good evening, sir.
Yeah, good evening. Are you just coming now? Yeah, in most of the
Yeah,
class.
yes, I'm in most of the classes, sir.
So, do you have any questions for what I've taught so far?
Okay, I messaged you, but I don't think you saw it. I have
On
laptop on
Discord.
this app, Discord, yes.
Okay, so you have what?
So I have a laptop issue for a while. I've got it done.
Okay, so you can keep up now. So go and do all your assignments so far.
Yes, so
Yeah.
I stopped at hello, sir, can you hear me?
Yeah, I can hear you.
So I stopped at stage 5, and I just submitted it, I think on Sunday, maybe yesterday.
I'll
But
look at it now.
I've watched all the videos, so I will keep up after you submit this one.
All
After you
right.
grade.
No wahala.
Thank you, sir.
All right. That being said, thank you very much for attending to this class. I will see you on Friday. Please, I'll try and find resources that will help you to download Discord. Sorry, not to download Discord, to install Terraform and install your IAM user for everything to be working, so that you know you won't have issues during the hands-on. Because me, I will just be doing my hands-on. Or you can be watching, you can be following. Yeah, I just wanted to show you how it's done in real life. I'll first of all I'll deploy an EC2 instance with a default VPC. Then your task will now be to do that whole setup with the custom VPC as well. So yeah, Thank you very much and have a wonderful evening.